Hi, everyone. Welcome and thank you for joining us today. My name is Jody Lee, and I will be moderating this webinar, effectively using high-resolution LiDAR for transportation asset and inventory management. I'm excited to be joined today by Tony Polizzi, Major Accounts Manager at Harris Geospatial Solutions. Tony has extensive knowledge about asset management, land management, and enterprise resource management. He has delivered mobile and custom solutions to multiple markets, including transportation. Just a couple of housekeeping items before we get started. I've muted the phone lines for all attendees, so if you have any questions at any point during the webinar, enter them into the questions chat box. We will answer as many questions at the end of the presentation, and if we don't get to your question, then someone will follow up with you. We are recording this webinar and will email you a link right after the webinar. And a recording will also be available online at www.harrisgeospatial.com, and we encourage you to share it with your colleagues. Without further ado, I'm going to turn things over to Tony.
Good afternoon or good morning, wherever you are. Appreciate you joining us today. Thank you, Jody. Just to start out right here with the agenda for this afternoon, we're going to get a brief overview of Harris for those of you who don't know who we are and haven't visited harrisgeospatial.com. I'll give you some examples of transportation applications and solutions that we have performed. And then a little bit about the Geiger-mode LiDAR system, some of the benefits, and some sample comparisons of Geiger versus other traditional LiDAR systems, and then summary and questions and answers at the end. And again, if you have any questions, like Jody said, just put them in the chat box there. So, introduction to Harris Corporation. Harris has been around for 100+ years. We're supporting customers in over 100 different countries. We have a high level of innovation and technology that we're delivering to a variety of different markets and customers. The group that I'm involved in, and Jody as well, is within their space intelligence segment. That's where the Geospatial group resides. So within the Geospatial group, it consists of a variety of different capabilities, if you will, from data collection, and that's all types of data, Geiger-mode being just one of many. Data processing. We do a lot of data management and storage, hosting and provisioning of geospatial data, and analytics, so online analytics as well. So the newest and latest is being able to access some of the analytical capabilities we have through ArcGIS if you are an ArcGIS user. We have a variety of different data that we provide through our marketplace. That's the Geospatial marketplace. So if you're interested in visiting that, it's on harrisgeospatial.com as well. So I'm going to go through a couple of examples of some applications that we're using our Geiger-mode LiDAR and just LiDAR in general with the analytics as well, both within Harris and other partners. So within the transportation asset inventory needs, this particular slide kind of demonstrates at least some conversations that we've had for a variety of different transportation customers. I think you're all familiar with the transportation infrastructure life cycle, if you will, but on the left, it's really about assets that folks are interested in. Not all these things are resolvable through Geiger LiDAR, but through different types of technologies to get to those points. But really, we're helping organizations both in the planning, design, for environmental, construction, mainly a lot around asset management and maintenance, security, safety, and right-of-way. So it's really about addressing some of the needs within the transportation realm, both around asset and inventory, as well as some of the other applications and our solutions that the transportation industry is looking to do. But first, I want to give a brief introduction here to the customer we're working here in North Carolina for the flood warning system, and then what's basically now a project that we're working on where we're collecting high-resolution LiDAR data with our Geiger LiDAR system for the mapping and alert system for North Carolina. This has been going on for last year or so. And the outfall of this is really not only for the flood warning system, but what's more important is that same data is being used through the North Carolina Department of Transportation. So here's an example of how we've done working with one customer, and now it's being basically utilized by other groups within the state. So in this particular example, the state DOT was comparing LiDAR technology used in that program for the collect in 2006, and basically looking at a variety of different things. So it's really to kind of do an independent evaluation utilizing that data and what they can actually glean out of it or resolve out of it, especially around DEMs and some other products, if you will, or other solutions that they're looking for versus a linear. So the highlights down at the bottom is really about what they found up to this point is, number one, we found that the data was less noisy to itself, less than 0.1 foot. We were flying at a higher altitude at 17,000 feet. So what they've found so far is the DEMs that they can create and utilize for planning purposes have been used already over 100 projects. And there's already seeing a very decent return on investment from that data and what they can actually resolve from the terrain and digital elevation models, etc. The next example is one project that we performed in Santa Barbara and Ventura County, California. This is through the Channel Island Regional GIS Consortium, which consists of multiple cities, universities, water districts, and the counties as well. This project was done last year. We collected the data at 20 points per square meter. We delivered an 8-point QL1 product, and that data is now being hosted through Harris Geospatial on our Geospatial marketplace. But some of the things that have come out of that, in addition to the QL1, if you're familiar with those USGS Quality 1 deliverables, is organizations are now using the high resolution data, mainly around transportation asset management, doing 3D buildings, looking at bridges, doing different activities in and around autonomous vehicles and a variety of other solutions that they've found that they can resolve the data out. So one of them is an organization, one of the users, is using it for asset inventory for transportation. So they're looking for guardrails and poles and signs, as well as doing asset inventory on their pavement. So doing not pavement analysis per se, but being able to determine where their pavement is and about what the volume is for that pavement using some other data that they have along with the high resolution data set that we provided. The next example is the Florida Department of Transportation in Pinellas County. This particular evaluation was done with Geiger-mode data for feature extraction and asset location. The data was collected in 2006 at a flight height of 12,000 feet. Again, collecting at 20 points per square meter with an accuracy of 0.1 foot, which was really assessed by the DOT. Harris worked with a couple partners, was Certainty 3D and who has Topodot and ESP analyst to provide the data that we were looking for. So the solution was really to evaluate and extract features from existing Geiger-mode data, compare that to linear. So using Topodot and ESP analyst, we're able to extract out different components, doing a DTM, guardrail lanes and barriers and slope. When it came to the mapping aspect of it, the assets were signs, street lights, electric utilities, drainage and slope, and other infrastructure, and then being able to do a sign and lane clearance from the street lights down there on the bottom right. The next one is an application from an analytical side of our business where we took, this is a railroad customer, where they wanted to look and find the network infrastructure. So they wanted to look at rails, signals, signs, road crossings, etc. So we did evaluating extraction features using machine learning Mega, which is a service that we provide, as well as some of the LiDAR that was collected along that corridor. So we're able to use the point cloud to extract using machine learning. We developed a quick algorithm, if you will, to train the system to find the information necessary based on customer requirements. And using that and develop it in an enterprise deployment, so this could be utilized multiple times. Again, an example of using different technologies, both from mobile LiDAR as well as Geiger, for example, to come up with asset inventory, if you will, feature extraction classification. So what is Geiger-mode LiDAR? Geiger is really a system that was developed around 16 years ago. We brought it to market a couple years ago. It was utilized in the defense space, and we commercialized it again a couple years ago. It's really a system that flies higher. It goes in a circular motion, uses a polymer scanner. If you want the technical aspects of it, and you would like to have that, just put that on the chat there, and we'll provide the technical aspects of it from technical questions. But really the key is we fly higher, faster, collect more accurate and more density, if you will, when it comes to high sample rate. So what does it really do is it improves the speed of which we can collect higher resolution data, improves a lot of things for like foliage penetration, for example, being able to get through that dense foliage layer when it comes to getting down to the terrain, being able to do the analysis, if you will, on that foliage, whether it's species classification, tree classification, for example. Reduces the shadows and voids, and achieves a higher accuracy, if you will, when it comes to a consistent, robust adjustment that we do when it comes to being uniform across the entire area. This particular video kind of gives you an idea of the comparison, if you will, between linear LiDAR and Geiger-mode LiDAR. Again, we use the right asset, if you will, for the right solution. Geiger being one tool in the toolbox. But really, again, this kind of gives you an example of the higher altitude. This particular graph or film here is really shown on a 8-point product, but we're typically collecting in wide area, typically around 20 or 30 points per square meter. So with that, and being able to do some overlap, we kind of avoid some of these linear artifacts, if you will. I'm sure some of you are familiar with these, from shadows to dead shadows and this compression and expansion. And that's really done by this overlap, if you will, that we do, so forward, side, and aft, and then forward, side, and aft coming back the other way. So really this improves the foliage penetration, removes those shadows, and eliminates voids, but it also gives you a true representation of that asset. It gives us a better opportunity to resolve different features on the ground, if you will, that we're collecting. So some of the other benefits, and we found this to be the case from a lot of opportunities and customers that we're dealing with, is really about it meets a variety of different customer needs. So again, a single flight of collection for multiple different resolution options. So for example, in the example I gave earlier around surges, we collected at a higher density. We delivered a lower density for the specific products that those folks need, but then gave them the opportunity to access the higher density data to do a variety of different things that would require higher density. And with the work that we're doing both in transportation as well as utilities, which are very similar, it's about being able to resolve that feature, if you will, with higher density data. The other thing is it delivers across different agencies. We have found in multiple cases, again, first example, doing one for North Carolina for the emergency management, flood management, the DOT was also able to use it. And there's several other organizations and customers within that area that are using that data as well. So being able to collect once, use many for planning, engineering, safety, science applications, whether it's for environmental, asset management, 3D buildings, parks, whatever, it gives an opportunity, if you will, to bring in more people, if you will, for that particular project, which we've seen on multiple occasions so far, where a variety of different folks will contribute. We will collect it higher and then be able to answer multiple questions with one collect. This particular example kind of gives you an indication, if you will, that higher density kind of does matter, if you will. So the lower right here is kind of linear at 32, same area collected at 12,000 feet with the Geiger mode in case of you getting 20 points or better. Another example here. So it's really kind of given a clear, not only the quality, but the ability to resolve the features in that data set. So again, feature details are important. Terrain and the accuracy of detection, the classification. So the example here going from 2 points to 20 points. And again, transportation is typically requiring a higher density, again, to resolve the data that they need, especially around asset management and then inventory management. So some examples of Geiger mode and data comparisons. This is just an example of an overpass. Up in the upper left, it's a QL1, it's a quality level 1 USGS to 8 points per meter, and then the bottom of 20, and then being able to see this with no intensity, it gives you an idea of collecting that at 12,000 feet. We're able to see a lot more information, glean that out, and resolve that, if you will, when it comes to finding guardrails and signs and striping and edge of pavement, etc. This is another example where we did down in Pinellas, again, from a cross-section perspective, gives you the opportunity to get a high foliage penetration, which is beneficial for forested areas. And this is very important when you're planning a highway or a road, when you need to do the environmental aspect, you need a very high resolution DEM to do that planning for a variety of different reasons. But being able to see that is very important. It helps with planning, it helps with permitting, helps with the right-of-way, etc. So you're really able to see. Also, we're finding that some of those assets that are on the side of the road, like culverts, for example, are easier to identify when you're able to actually get through the foliage. Just a couple of other examples, just some comparisons. Again, this is just comparison between linear and Geiger. It's not that one is better than the other. It's just a matter of just showing that being able to collect at a higher resolution in a wide area is in this particular case it's better. But when it comes to smaller areas, for example, certainly you can get that type of density with the linear perspective. Again, Geiger is designed for wide area collect. A couple other examples here. Again, with the uniform characteristics around what we can actually resolve out of the data. This particular example here is one that was done in an independent study when it comes to the results, if you will, from the vertical on the hard surface. So again, it was compared to a linear, and we were actually flying this at I think it was 17,000 feet, I believe. And so we were able to get again, this is not done for, or could be used for pavement management, for example, but to give you an idea of some of the features on the road, if you will, and then that cross-section, you're able to do that, again, from a higher altitude. So what does that mean is you can collect more roads, if you will, more assets, more information with one collect. So summary of the asset applications and benefits, if you will, are again, higher accuracy terrain and topography. These are just a few. The road geometry, being able to resolve guardrails and barriers and signs, slope, street lights, bridges, etc. And then being able to provide that information for your asset inventory and meeting some of the requirements that are necessary not only for, let's say, from F21, for example, or other asset regulations, but also for environmental purposes and the permitting and planning and engineering. So again, one collect, many uses. What I want to also mention here is that one of the benefits as well is being able to get a wider area, get your information, and then go back and use other modalities, if you will, from mobile mapping, terrestrial, et cetera, to kind of fill in the blanks, if you will. So that's kind of the mode for which most of the customers that we're talking to are kind of looking at this particular point in time. So with that, if you have any questions, I'd be happy to answer them to the best of my ability. Again, if it, two things. One, if it's a technical question about the sensor itself, just let us know and I'll provide you with that information. And then if you have information that you need around costing, time, schedule, etc., I'll put that in there well, and we can answer those kind of separately on a one-on-one basis. But I'd be happy to take questions at this point in time.
Great, thanks Tony for the informative presentation. If you have a question, enter it into the questions chat box in your GoToWebinar dashboard. With that, we'll get, so one thing I do want to remind everybody, we are going to send out the recording of this webinar right after the webinar ends, and then next week you'll receive another follow-up email from us with a PDF of this presentation, as well as a Q&A sheet, and then a link to our sample data. So if you want to download Geiger mode samples, we offer 5 different samples, and we'll give you that link. So the first question is, can Geiger mode LiDAR collect in the daytime?
Yes, it can. We can collect day and night. Typically, we're collecting at night for a couple reasons. One is, well, for one of the biggest reasons is there's less cars on the road, so that typically helps when we're collecting at night. A lot of times we can, certain areas we can collect more during that period of time, if you will, when it comes to the type of information that we're trying to resolve. So in most cases for transportation and utilities, for example, we'll do that at night because there's, again, less the movement and less other assets, at least assets that we'd have to, get rid of, if you will, when it comes to cars, for example. So less on the road. But the answer to the question is yes, we can collect during the day or night.
Great. So Benny has a question. Do we sell the sensor or do you only service it?
Yeah, currently we are, this is a service. We're not, we didn't build the sensor to sell it, but currently it's just a service at this point.
And then he has a follow-up question. What is the minimum area appropriate for the sensor?
The ANOI is really kind of determined based on the opportunities that we're pursuing. So obviously we try to get larger areas, and what that could be is, in 500 square miles. We do less than that, but really depends on where it is in the, where we're collecting it at. And the application and the customer that we're providing it for. So, but rule of thumb, anywhere probably 500 square miles or above, but we've done ones that have been less than that.
Great. Can Geiger mode LiDAR be able to ascertain the gradient percentage slope of a curb ramp? It'll be used for ADA curb ramp inventory data collection inspection.
Yeah, that's a very good question. I know that we're in the process of evaluating some of those things, especially around ADA. At this particular point, I think we're in the midst of that evaluation. So with that question, I'd like to follow up, if you don't mind, after our evaluation is done, and provide that information to you around that. Good question, though.
Great. Is accuracy of the data uniform?
Yes, accuracy of the data is uniform across the entire area that we collect. So, for example, in areas in North Carolina, example, and those, it is definitely uniform. And the reason for that is because of the production and the bundle adjustment, if we do through our enterprise process that provides that. So, yes.
All right. And then, can Geiger be delivered in different formats? And somebody actually asked if they can use it in the UAVs, or with UAVs. Well,
it can be provided in different formats. The answer is yes. As far as different formats, datums, etc. So the answer is yes. As far as the UAVs, I'm not really sure what they mean by that, but it's basically being used in multiple different types of applications.
Great. The next question, is it only a single return versus a multiple return? How does it achieve better bare earth under vegetation?
Well, single return, it's a photon counting, so we basically, the rule of thumb is if you can look underneath the foliage and look up and see light, we'll be able to get through it because we'll be illuminating that spot hundreds of times as we go forward and back. So that's how we're able to get through there.
Great. Let's see, the next question, somebody asked, what other industries is Geiger mode used for today?
Currently, we are working in a variety of different industries, so state and local, federal, as well as natural resources, specifically around forestry, utilities, of course, transportation. Most of the customers that we're delivering to are looking to resolve not only high-resolution dams, but they're also looking around resolving other assets. So those assets could be trees in that case, where we're able to get down to the species type, as well as the ground cover and ground. Utilities are looking at it for poles and wires, as well as both on the distribution and transportation, or excuse me, transmission. They're looking again for just pavement for transportation, as well as guardrails and culverts and signs, etc. So really from a 3D perspective, as well as other commercial industries like insurance, for example, being able to build robust 3D models, if you will, of those assets.
Great. There's several questions about where you're able to shoot this high-resolution LiDAR. Somebody wanted to know if it can be shot in Africa.
Yeah, we are have opportunities globally. This is not just the U.S. So we look at those on the international side. I'm going to say on a case-by-case basis, but we're able to do work anywhere. Well, anywhere, I guess, where it's permitted, I guess. So the answer would be, if you want to give me that information, I'll bring it over to our international account manager, and we can handle that on that basis, if you don't mind.
Great. Richard says, I've noticed some burst effect in the data when the sensors hit a reflector, such as a construction cone. How do you get around this issue? Maybe that's just a more technical issue, but.
Yeah, I think that's there's several ways that we could do that. I'm not the person that could address that to that degree, but if you want to take that one, I'd be happy to put you in touch with our engineers and production folks, and they'll be able to answer that one for you.
Great. And then what is the turnaround time from flight to data set for the user?
Typically, it's about currently it's about 2 to 1. So if it takes a month or 2 weeks or whatever to collect, depending on the size of the area, or 2 days, it's typically 2 times that much in most cases. And it really depends on our current production, and because we have 3 sensors now that are working and collecting and producing. So it really depends on that schedule as well. But that's probably a good measure. Maybe a little more depending on our current production schedule.
Great. Maybe just a few more questions. Has Geiger mode been accepted by USGS?
Yeah, we're in the process of that acceptance. So we've been going through an evaluation, and we are getting very close to that at this particular point in time, so more to come on that. But we have delivered and collected several projects at this point in time that meet the QL1 requirements from USGS.
Great. And then how has Geiger-mode LiDAR responded to high elevation collections through steep corridors?
Okay, say that one more time, Jody. I didn't hear that too well.
So how has Geiger-mode responded to high elevation collections through steep corridors like mountains?
Oh, mountains, etc. Yeah, it usually when we go through do our flight planning, obviously that's something we take into consideration is the elevation. So we'll adjust the flight plan for that. We do have some data available, I believe, for urban corridors. We did a project or in process of completing a project up in and around the Chicago area, and have some kind of urban corridors, but also have some data available as well for mountainous areas as well. So it really depends on the terrain, and that will be adjusted both on the flight, the sensor, and the post-production for that to resolve those issues. And I know those are issues that come into play, especially when it comes to high elevations.
Great. So we actually have a lot of questions. So we're gonna wrap things up here. But we will put together a Q&A sheet and send it out to you, everyone that's registered next week, along with the PDF presentation and a link to the webinar and a link to the samples page for downloading some samples of Geiger-mode LiDAR. If we didn't get to your question, then we'll follow up individually with each of you, and we will send you a link to the recording within the hour right after this. We appreciate everyone's attention on the line, and thank you, Tony, for the amazing presentation. So have a great rest of the day, everyone. Thank you.
Thank you all. Take care.